Hey there, I'm Cyber Chroma, and have you ever done any pathfinding? Well, in Unity, there's a fancy thing called a nav mesh that allows you to set up some values, push some buttons, and voila, you can get a character or anything to move from point A to point B, go around some obstacles, and yeah, it works really nicely. Now, what if I told you, with the thing I'm showing off today, that I didn't do any of that? I had to make a tag game for a school project, and I wanted to see, for no other reason than I can, if I could make my own pathfinding system that also, because of the fact that it's a tag game, does stuff of deciding who to chase and where to go, more than just going from point A to point B. But yeah, I did some custom pathfinding stuff to a varying degree of success, as we'll get into. And not only that, but the way it's done is so good on performance that after doing a million calculations before the game starts, going into the game, it has a time complexity of constant. That's right, it's just a bunch of if statements once it gets into update. Now, how is that possible? We're gonna get into that. And not only that, but having a bunch of different characters that are running around this map, they all share a bunch of information, which makes each individual one that you add really, really good on performance. So a lot of cool code things that I wanted to show off today. So without further ado, let's get started. All right, so I wanted to open on this guy because this is easily the greatest thing to come out of this project. This is Rotten Reginald, the character that I made is like a villain. Because the theme I was going for this tag game was like spies and like spy movie villains. So this is Rotten Reginald. You can see some of his topology there. He's got a mustache and top hat and all that stuff. And yeah, fun fact, this guy was made using my animated me for my intro and outro. This was used as a base to make this guy. And we also have our protagonist here, Agent Ivan, which acronyms to AI, which sure. This one is not as good. I struggle more with this. Also, he doesn't even have much of an expression. That was the thing I was going to do and ran out of time and never did. Yeah, so that's that. Anyways, over to the Unity stuff where we're actually gonna be looking at things. First things first is that graphically it's not as good. It is in the HD render pipeline, which means the lighting's pretty cool. And also a skybox that I did not make, but that would be looking cool as well. But the characters here, yeah, first of all, this attempt at doing some outline stuff didn't really work out that well, but it's something I would might revisit and try to make better. So I think we're gonna start by just getting into the game, and then I can explain things further. So this is a tag game, and not just that, there's a lot of customizability in what we can do here. So it's a tag game where these characters run around, and the first thing I wanna say right off the bat is that the pathfinding isn't perfect. This, mainly with jumping, is like the one spot that it breaks. And I was trying to make it better, but for a lot of this, yeah, this is all custom pathfinding. There is no Unity nav mesh stuff. It's all like rigid body stuff and them just deciding where they need to go. Now you'll notice that some people are red and some people are green. That was my attempt at just having a way to tell who is it and who is not it, because it's a tag game. And to better say things, rather than saying it and not it, I was calling these people like runners and chasers. So runners being people running away who are not it, and then the chasers are the it people that are chasing, so just makes it more distinguished. Anyways, so in this area we have two people, so two runners and two chasers, just because it's a thing I was able to do with yeah. You can see in the bottom right we have a mini map that is like a top-down view of the level that shows where the characters are, and they have little borders of being red or green depending on whether the characters are it or not it. You can see that everyone has their own little character icons, which is pretty cool. Now there is like, because I only made two actual Blender models, there's like two duplicates of everyone. That's just how it is. I just would have to make more. So basic idea is that the green people are running away and the red people are chasing. If I touch anyone, they will turn red. Oh, I touched someone and then immediately got tagged myself, I think. Yeah, if I tag someone, they get stunned for a few seconds, and then I can run away. If someone touches me, I get stunned for a few seconds, and then they get to run away. And it's tag, right? That's how this is. Now you'll notice some bars at the bottom. My attempt at showing like who's winning and all that. Basically, if you are running away, your score is going up. And oh no, Bad Berry won. It was just some alternate names I had. if I restart here, you'll see the top is me, however I am, and then the bottom one is whoever's in first place. And if I'm in first place, then it shows whoever's in second. That was my points scheme, how I went about doing that. So yeah, I can tag people, and now they're chasing me. Yep, they be doing that successfully, and oh no, I got tagged. Yeah, graphically, I think this could be a lot better, but there's a lot to be desired. But it's the programming behind this where I think the real beauty shines. So we go out of here, and the first thing I want to point out is you see all of these speckled dots around everywhere. Well, this is how the magic is happening behind the pathfinding system. This could also be improved, and also just making it actually work. There's been this problem area where they think that they can jump up this when they actually can't, that I'm just trying to fix, and maybe I will be able to figure that out eventually. But they are able to pathfind on the ground perfectly. I've had no problems with them pathfinding on the ground, and even falling off stuff. It's just specifically sometimes they think they can jump over things they actually can't. That's like my one problem that I'm still trying to sort out here. But anyways, there's all of these empty game objects all around the scene. And if I go and turn on a little bit of this, then you can see, yeah, how this is basically what the AI is seen. And let me also clarify that when I say AI, I mean like the video game way of how you refer to AI, just like a non-player character in NPC. I don't mean there's no like learning going on here. It's just all hard-coded. Not hard-coded, uses this pathfinding stuff, but you know what I mean. But anyways, all of this represents basically what the AI can see in terms of how it navigates around the map. This is almost like my version of a nav mesh, where the blue represent connections that are like two-way connections, and the red represents one-way connections that's usually top-down, which is basically used for falling. You'll also notice that there's two colors of these waypoints here. There's the green ones, which are just on the ground, and then there's red ones that are like in the air, like right off the edge of a platform. That's just the way that this happened to be. Now, I can actually control the density of all of these, and that affects how well the AIs are able to navigate around the map. Now, also, I did not place all of these manually. Initially, I did have a system in place where I did go through and place a bunch of these manually, so they weren't this dense. By doing it manually, I was able to have a lot more control over having a lot less of these waypoints more controlled, but it would have been a pain to set them up for every map I make, and having to also set up all these connections and yada yada. Having it be more automated was something that I wanted to try. So I actually have some editor tools going on at the side here, where I have some buttons here, and I'm not going to press them now because I don't want to mess up the pathfinding thing that's currently in place. Just trust that I have 4 buttons here: generate waypoints, reduce waypoints, calculate paths, and clean up. So when I hit this generate waypoints button, it generates all of these dots everywhere, and they're actually a lot more dense at first, because then I have the secondary thing that tries to clump together to a degree some unneeded waypoints, just so there's less of them, because obviously the less that there are, the better the whole thing will be on performance. Currently there's 4,503 of these in the map total, which is a lot, especially when we get into the part we're about to get into, where sort of the bottleneck of the calculations happen. So when I hit generate waypoints, it spawns all of them in like a grid faction. Basically, and I can control the density, but with the density is currently set at in this kind of density, but all over across the entire map. And then, yeah, it also sets up all these connections between all of them, where basically anything on the floor, it makes all these blue connections, and even going up thin slopes or thin things you can jump up and fall down, then yeah, there's more of these blue connections. And then yeah, it also generates these red connections where you can fall, but you can't get back up, which is usually just, yeah, on the edges of ledges and whatnot. Then I have this reduce waypoints button that, as I said, tries to then go through and just tries its best to sort of clean up some unnecessary waypoints. Anything I could do to make this better, to have less waypoints, would be good, and that is something I'm looking at trying to refine. Definitely, it could be improved further. This is just the current state of it. And then, sometimes, because my code isn't perfect, trying to reduce some waypoints leads to some, if I click on any of these individual nodes here, like this one, you can see it has all these connected objects and shortest path next steps, blah, blah, blah. Sometimes there'll be some like empty things in the arrays. So I have this cleanup button that just tries to like get rid of anything that's empty in some of these arrays, just because then it shouldn't be there, and it makes some of the calculations a bit better. And also smooth that up. Okay. So also, this is a good time to point out that what is on each waypoint. What is it actually storing? So first of all, it has, the connections between all of these surrounding waypoints, which is all of this. This is waypoint, this one is 766. They're all named based on, just increasing order of how they got spawned. And then I also have, as part of their name, basically their position in the world. Just helps with identifying them, all being unique and whatnot. So I have all these stored connections to every waypoint that is surrounding it. And this is what we're gonna get to in a minute. The next thing that happens, as I said, the sort of bottleneck of how all of this is able to be efficient after it's all calculated, is this calculate paths button. Now, normally when you want something to go from point A to point B, you will in the moment do some kind of a pathfinding algorithm. Say we're at this waypoint and we want to get over to this waypoint. Well, then we can just go and call some code that's maybe going to calculate a shortest path. And there's a lot of different algorithms named after a lot of different computer scientists that go about doing that. Now, what I wanted to do is, rather than generating all this information on the fly every time that an AI wants to navigate around the map from one point to another, instead I generate all of it. I have this calculate paths button that goes through, and for every single waypoint of the 4,500 that there are, it calculates what is the shortest path to every single other point in the map. Sort of. It's basically that, but it's slightly less than that. More rather than just each point calculating the shortest path to every other point, it says, if I'm here and I want to go there, what is the immediate next node that I need to go to? So, as an example, we have this node here. If we wanted to go to this node here, let's go with this one going to this one, right? If we're here and we want to go over to this one just knows, okay, if I want to go over to that one, my next immediate node I need to go to is this one, or this one. Let's just say it's this one. And then, okay, now I'm here. I still want to get over here. What's the immediate next node I would travel to? It's this one, and this to this to this. So each node keeps track of, if I want to go here, here's the next one I go to, and here's the next one I go to. And I calculate all of this information on, well, not even on start. I have this as editor button, so code that actually runs in the scene view, like before I go into play mode. I press a button, my computer freezes for like 10 minutes, and then basically on all of these 4,500 objects, it fills in this table or this list with all of these numbers. Now, what do these numbers mean? Initially, these were just the game object references of, okay, if I want to go to waypoint 964, then the next one I need to go to is drag and drop reference to whatever waypoint that is. But to make it more efficient, I just have a bunch of integers, as you see, that if I scroll to the top, they just link to these connected objects. These are all of the possible connections, that a lot of them are shared. If we are at this waypoint here, if I can click on it, having all the lines, it makes the scene view kind of slow, so I might turn them off soon. But drawing all the lines is a lot. As you can see, there is just a lot of lines. But if it wants to go from here to here, or here to here, the next immediate node that it would travel to is this one in both of those cases. So it's kind of linking some information together. So yeah, long story short, that is how... That is the overview of how it's calculating all of this path stuff. And it's using something called, I can never pronounce this right, Dijkstra's algorithm, which is vaguely like this. You can see it if I put it over here. Yeah. No, hold on. Which vaguely looks like this. I was trying to find a good image to describe it, but yeah. This basically, if you're trying to get from one point, looking at one point, and you want to calculate the shortest path to every other point in a graph, or that's the term of what this is called, then yeah, there's an algorithm of how you can go about doing that. And it uses something called, well, costs between each points, which the way I'm using it is just the distances, like the literal position differences between one point and another. So yeah, that is that. So then once this information is generated, I can go into play mode and the AIs use this information. So let me turn those off and wow, I can move around with speed again. So yeah, with that information existing, it is something that every AI accesses. So you see here I have, well, the player character, and then I have 3 other NPCs here. We got like Agent Arthur, Rotten Reginald, and Bad Barry. It's just random names I came up with. However, I when I did this beforehand, I can just duplicate the characters around, and I had to do no other setting up. I literally just duplicate, drag them somewhere different, and I believe the code will just work. And go into play mode, and voila! It just works. No errors. You see, there's a bunch of characters in the bottom right running around. Now most of them are the same purple background guy because I just duplicated them around. But my point stands. They're all running around, and they okay. Pathfinding isn't perfect, but mainly when it comes to jumping and falling. But they are navigating around, and it's really fast on performance. As I said at the beginning, their movement comes down to just if statements, no loops, which is pretty cool that that's able to happen. And not even like on start is there that many calculations. So yeah, very, very cool. Now, how does an AI actually decide where to go then? Because now we have a system in place of if they are someplace and they want to decide to go to some other place, they just have to look at the next node to travel to. But how do they know where they want to go? Well, because it's a tag game, the rules are simple. If they are trying to run away, if they are not it, if they are a runner, they just try to, whoever's it, whoever they decide they're running away from, go to the opposite side of the map from them. Which is another part of the algorithm I forgot to mention. For every waypoint, not only does it know, I don't think it's a public variable. Not only does it keep track of here's all the directions I need to go to get to different points, it also keeps track of the farthest object from itself. So any waypoint knows what waypoint is on the other side of the map. And that's also not just a distance thing. I could compare all the distances, but if I had a weird map where, there's 2 waypoints that are kind of close together, but there's a wall in between them, then those waypoints are actually a lot further away from each other than just the distances would make you think. So it actually goes off of basically like pathfinding to the furthest object, to the furthest waypoint, to actually navigate from where it is to the furthest place in the map. So that's another thing that all the nodes keep track of that is calculated when I do the calculate paths button. So runners just try to go as far away as they can from whoever's chasing them. The chasers then are just trying to chase whoever is it. Now, there's where there's like one for loop that goes on that just decides if we're it and we're chasing someone, decide who to chase, which is just looks at all the characters and which one's closest to us. An AI that's chasing someone or chasing any number of non-it like runner characters, it just says which one's closer, chase them, and then it does that. And a lot of that just comes down to then finding what waypoints are closest to the characters, because that's another thing that's important for this system to actually work, is that any character needs to know what waypoint is closest to them, which is just through some distance calculations that are also made better on performance through the use of a bubble. If I want this character to know which waypoint it's closest to, rather than looking at every single waypoint in the entire thing, it just has this bubble with some on collision enter, on collision exit stuff, or on trigger enter, on trigger exit stuff, where anything inside the bubble is fair game for doing all these distance calculations to just see which one's closest to that particular player. And that just saves not having to do these like distance subtractions with every single waypoint in the entire thing. And yeah, that is basically the overview of the code. I wanted to explain it more verbally and by like showing what was going on. I can go and show off the code, but this would be a lot harder to. It is very, very complicated. And I can go through some of it, but it's basically what I just tried to explain, but the actual code that's going on here. This part specifically, so this is my pathfinding editor tools, the stuff that is running in the editor. These are functions that get called when I press those buttons. So generate waypoints goes through this algorithm here that, as I said, generates all these waypoints in this grid-like fashion, where it does a lot of ray casting to decide what's floor and what's in the air, and also deciding that like a point isn't in a wall, deciding if a point is an air waypoint or a ground waypoint, because that was important for just how I was going about some of these calculations. Initially, air waypoints can only spawn above ground waypoints. So for an air one to spawn, it has to raycast down and see another ground one before we do the reduction. After we do the reduction, then that's not really the case anymore. But yeah, that's how that happens. And if I go down here, yeah, this part has to do, I think, with spawning air connections specifically. Because, yeah, they're complicated. Because also to making sure that these air waypoints, they have to be able to be connected to a ground waypoint. They can't just be floating off in the middle of nowhere. I mean, they could have, but I wanted that not to be the case. It defeats the point of why I need these in the first place. Ideally, it would be great if I didn't need them, if I could just have, like, this one be connected to one below. But I wasn't able to get that to work in a way that would work all the time, because again, I'm trying to come up with a system here that works with the least amount of manual labor as I can. Because the idea would be if I make like lots of levels or whatever, or even any changes I make to the levels, I just click a few buttons and then it generates everything. Would be really, really nice. Yeah, so that is that. Then we get to reduce waypoints. As I said, this just goes through, and this one's more complicated and just weird, but basically anything I could think of to go through and determine like, okay, this set of waypoints, they're definitely not important to have both of them, so fuse them into one where they share like the information that both of them had in terms of what they were connected to, and then the position goes to like the middle, the average of both of them. And yeah, this works decently, but again, anything I could do to make this better, any like single less waypoint in the map is less calculations that it has to do. To a point. Of course, if I reduce too many, then there can become some problems. Especially in like tight areas or like along certain like catwalks like this, I need to make sure that things are being generated in the right place, that no paths get cut off for the AIs, because that would be bad. Especially like I have this tight like maze area, I need to make sure that the points actually work as they're supposed to, which, yeah, was tricky. But this ended up working pretty well. Yeah, so then we get down to, this is the cleanup thing that just goes through and removes any null references in any of the lists, just in case that happened. I don't think, do I not have the calculate paths in this code? I don't think I do. It's somewhere around, oh no, here it is, yeah. This is then the sort of bottleneck of the entire program, where as I said, if I call this, it can take like 10 minutes to run. It depends on what other settings I set with like the density and how many waypoints just there are in the map. But the main bottleneck comes down to this triple for loop, where each one of these is running currently 4,503 times, which again, if for any time I can reduce a single waypoint and get that to 5,502, 5,300, or 4,501, you know, whatever, then this runs significantly faster. So, yeah, that is, but this is just the consequence of using the how do you pronounce it? Dijkstra's algorithm of, from a single point, calculating the shortest path to every other point. Actually, then this part goes and does the furthest object part. Yeah, but again, once all of this happens, then as you saw, it ran pretty fast when I went into play mode. Currently, the biggest performance draw when I go into play mode is just the graphical stuff. The fact that it's the HD render pipeline and the like polygon count and vertex count that goes into the characters themselves. So, in theory, I could maybe try going for like a more simpler art style, and then I could be able to have hundreds of AIs. And that was something I was experimenting with. When I made this game, it being a tag game, when I submitted it for my school project, I basically just went with these 4 characters just to kind of show off the main things of one, it just being a tag game, but also I am able to easily change rather than like usual tag games. You might have like one it character and one non-it character or whatever. This code can currently support any number of characters that are considered it and any number of characters that are considered not it. And it just works. Basically, all I have to do is down here, I just have to fill in this this array with the characters that are meant to be it at the start of the game, and everything else does all the busy work in the background to make it work. Now, again, graphically, this isn't the best with like how some of this outline stuff is, but I did my best at the time. But yeah, if I were to continue to work on this game and try to expand it beyond just trying to improve the pathfinding system to work better and work in different scenarios and just be more optimized, yeah, potentially working towards a game where I could just have a bajillion characters running around in a map. I think that could be a cool, neat, and unique thing to try and make. And the code here could support different game modes, I think. Like you have the normal like 1v1, you can have like one person it versus like 100 not it characters. Or like 100 it characters versus one not it character. Like there's different things you could do with that. The sort of thing where like a hot potato kind of thing where after so much time, like certain characters get eliminated and you have to be the last one standing, or like a zombie-esque thing where you touch someone and then you're both it, and then you have to keep going getting everyone it until there's only one person that's not it. That kind of stuff. Like a capture the flag type scenario could work in something like this maybe, and a like a team sort of thing. Right now it's like a free-for-all where even if multiple characters are it, it's still kind of a free-for-all, but doing it like a team thing where it's like 2 characters it versus 2 characters not it, and somehow if one person touches another person, then like the status sort of changes for both characters or something like that. I think there's a lot of interesting ways that I could continue to expand upon this. And again, first part of that comes to fixing some of the code, because it is still, it's cool, but it is, well, one, it's really complicated, but it still has some problems, as you saw with some of the jumping. I also wanted to dabble in just the fact that, so as I said, I didn't use Unity's nav mesh system stuff for this, and maybe I should have. Maybe this would have been far easier if I did, but it's part of just, for the sake of learning, I wanted to try not doing that. And I think I learned a lot while doing this and made some cool things. But more than that, I know that there are some problems of certain things that Unity's nav mesh system can't do. So what I was thinking that I almost want to do is make my pathfinding system specifically able to do certain things that I know that Unity's nav mesh system can't do, or at least not do well or easily. One of those things is jumping. Unless I'm mistaken, Unity's nav mesh system can kind of do jumping, but it's weird, and you kind of have to set it up manually for every jump point, to my understanding. So it'd be cool that, mine can jump anywhere, and which currently is kind of the case if it was working. I also wanted to dabble in maybe doing some anti-gravity kind of stuff. It'd be cool if you could have a character run up a wall or something like that, and then again have the pathfinding work with that. And also if I introduce like hazards and whatnot. I had an idea of like with these nodes, have like a third color. It's like, well, the color doesn't matter, but let's say it was blue. It's like a hazard node that like an AI could know, like if I run through this node, there's like a chance I'm gonna get hit by some hazard, but it might be worth it if it's way faster to get to where I wanna go. It might be worth running through here, getting hit and getting like stunned and then keep going, different functionality like that I thought could be cool. Another thing this is missing that would really make the game a lot better is actually having hazards. This was sort of something I just ran out of time with doing, but the idea with this is that I would have these levels be filled with all kinds of hazards. And I was thinking of also giving the characters themselves kind of weapons, basically like an offensive weapon of some kind and a defensive weapon of some kind, mainly just to be able to, if you're chasing someone, you like throw something at them and it'll like slow them down, or if you're running away from someone, you can like throw something on the ground and it would like slow people chasing you down. I thought that could also be stuff that would be cool to experiment around with, that could improve the gameplay and whatnot. But and then I could play around with having different types of those weapons, and then you go into a level with kind of like a loadout of what weapons you have active. I'd also have to then get the AIs to actually be able to use these weapons. But that's all stuff that would just be future plans to maybe do. I finished this game back in December, about like almost half a year ago now. 4 months, but I like how this game turned out, and I'd like to maybe pick it up again at some point. Just I think it'd be cool to maybe try to implement some of the ideas that, as I said, I think the first thing I would do is I might actually turn this entire project from being in the HD render pipeline to being in the universal render pipeline to match how my other game I'm working on, the Handyman with the Unicycle, currently is. So I'd like to have them just be more consistent if I'm kind of working on both of them not at the same time, but going back and forth or whatever ends up happening with that. And another thing, I guess, probably wrap things up soon, but one other thing I want to mention is story-wise. I did have some ideas for like what the story of this game could be. Art-wise, with some of the characters, like I have this stereotypical like kind of villain. I was thinking that the story of this could be like a spies and spy villain sort of thing, where every level is all like secret villain hideout themed, and you're like going through all these hazards trying to like chase the villains and catch them and all that. Now, how does that make sense as a tag game? I had the idea that like they've stolen something and then you're just trying to get it back. So you're trying to have this thing in your possession for a certain amount of time and then you win the level. And I thought that would be an interesting thing it's like the simplest thing that like justifies the gameplay, right? Giving it, we could have a certain theme to it that could be interesting. Now on that, as I just said, having levels, you could have a game like this that's just like an arena, it's just a multiplayer kind of thing. But I think it'd be cool to like, have like a campaign out of this where you go through different levels of increasing difficulty, increasing like complexity in the AIs that you're fighting, and as I said, with weapons and hazards and all that, I thought that could be a neat thing to try and do. And if I do go the multiplayer route, it would give me a good excuse to experiment with networking and like online multiplayer sort of stuff, which is something that I've never done in Unity and would like to experiment around with sometime in the near future. So I think that's my biggest incentive to continue working on this game, is to have that excuse to just try to get online multiplayer to happen. It's be cool to learn. But anyways, I think that about wraps it up for everything I wanted to show you. No, it doesn't. There's one more thing. Ha 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 ha. I never mentioned how I went about making this level, the sort of level design that went into this. Now, yeah, it's just a bunch of blocks pasted around. But I went off the deep end with how I went about constructing this level, where I have this. Do I want to? Yeah, I'm going to pull up the layout where I have this set up. I have a fancy layout like this. Now, you might ask yourself, what am I looking at here? Well, you see how this vaguely resembles the level? And actually, to be fair, this is a slightly earlier version of the level where there was a lot more jumping going on. But then when everything was not working with the jumping, I actually just reduced the number of how much jumping there was in the level. But I wanted to try something with how I wanted to go about doing level design that I had a decent amount of success with, and I kind of want to continue trying this idea where I basically used Unity almost like a whiteboard or like Photoshop or something, where I just have different shapes that I copied and pasted around with a kind of a color scheme where white is something that you can walk on, black is something that you can't, like a wall. In this case, yellow is like stairs or a slope that takes you from one floor to another floor. And yeah, I built a level like this where I had these different cameras at or different like scene views looking at different floors. And there is a thing where, to a degree, I can grab like, I haven't worked on this in a while, but I have ways of be able to like box select things and like move them all around. And there are some things that are shared between floors, I believe, where I could like move this and maybe not. Okay, I haven't looked at this in a while, but yeah, this is something that I use to do sort of the level design for that level that you just saw. And there's also little things here for a spawn point of like the player, and at a spawn point of one enemy when this is going to be just a 1v1 thing. Yeah, now the actual, if I go out of, let me go back to just the default layout here. Yeah, that works. The behind the curtain of how this is being done is like this. Everything's flat, and then yeah, I have these different layers just in the air. Like here's the top layer, here's kind of like the middle layer, where again, white is stuff that you can stand on or like jump across, and black is meant to be all walls. And then I just have like these transparent layers in between. And this was very, very much in this kind of unorthodox way of going about this, but it worked for me, and yeah, worked quite well. So something I might experiment with again in the future. This is like my equivalent of like drawing a level on paper, but in this case, it's much easier to, like, I have these green blocks that represent the player's jump distances. Like, this is how far the player can jump across, and I think I have another one. I think it's actually as tall as the player's jump height. So I was able to use that. This is kind of like a ruler to see, like, okay, if I put this block here and this block here, then yeah, the player can jump across that, and how hard is it, and all that kind of stuff. And then it was much easier to, well, I mean, I can just copy and paste stuff around. It's easier to like move things around, as opposed to if I was doing this like on paper or whatever. Well, one, you have the problem with just like running off the edges of the page, and yeah, you can't just duplicate things around as much. And this gets a nice, like much easier sense of scale. And then when it came time to build the actual level, I was able to just copy and paste a decent chunk of this. Oh, don't know why the lighting just now decided to exist. But I was able to copy and paste a lot of this just into Unity and use this to block out the level. Now, of course, the actual level as it looks now is still just all very blocky, but the idea would be then I could take it and actually do textures and all that fun stuff. And yeah, in my case, it worked out quite well. I also had a few other scenes here. I guess I could show off real quick. Is like this, where I was just experimenting with some graphical stuff. I found some picture online that I then tried to like recreate with some degree of success. This was me just trying to get better at like, not just 3D modeling, but also like on the Unity side of better lighting and all that. Is this what I think it is? Oh yeah, this is a scene I was using. Oh yeah. Okay, here's a good demonstration of how a lot of the dots were initially. This was a scene I used to do a lot of testing with the waypoint generating, where it's got a bunch of things with like slopes and stuff that's like in the air. Yeah, things that you could like jump on and like fall off that were like pretty low. And yeah, again, this worked quite well for me to build that system that I made. You also notice that so the original level, like the actual level, is a complete square. This isn't, but it doesn't draw these green dots like out in the void here. There's stuff that prevents that. So yeah, that was pretty cool. Do I have anything else? Yeah, this test level. I don't think so. Oh, I had this scene that was specifically used for making those little profile picture things. Like this one is how I made Ivan, and I don't have. Do I have the one for? Oh, there's for Reginald, except he had a different camera angle when I did him. But yeah, that was just used to take those screenshots for the thing. Like for the little mini-map icons. I guess I never talked about the mini-map. It's not really that much related to the tag part of this, but someone might find it interesting. So I have these things here, scriptable objects. Actually, let me put myself on this side real quick. Over that way. Basically, this just has some information that is used to generate the little mini-map icons, where for every character, I have the color of their background and then what image to use, where at the moment, there's just 4 of them. But it works, it did the job, and I could easily make more. And if I had the same characters in different levels and I wanted to change some of this stuff, I just have to swap these colors out here, and then no other problems there. So yeah, that's, I think, wraps it up for Ultra Tag. And also, this didn't have much of a name, just because, it was just a tag game for a school project. I think if I were to continue working on this, I would give it like an actual proper name. I don't know what yet. Something spy related, maybe, if that's, as I said, that was a theme I was going to go for. But yeah, anyways, that's it for Ultra Tag. So those were my misadventures with Pathfinding. I hope you found it interesting. I know a lot of it was probably very confusing. It was for me too, as I was doing a lot of research trying to figure out how to actually do the crazy idea I had for this really complicated pathfinding system. I do kind of want to do some research into how some of the programming behind Unity's nav mesh thing actually works, and maybe in the future I'll replace having those waypoints with almost doing like my own mesh generation stuff. It's an idea I had. I don't know how well it'll go because again, it's all still very, very complicated, but cool to play around with. Sometimes, yeah, you just gotta do crazy things to learn cool things about programming and whatnot. Now, I don't know the next time I'm gonna pick this game up. I do, like, as I've said, I have a lot of other things I'm working on in the meantime, the main thing being the handyman with the unicycle. But at some point, I think it'd be interesting to do some more stuff with this game. As I said, to like experiment with like procedural mesh generation and networking stuff and just different things I could use this game as an excuse to just learn new things, new territories of Unity that I have yet to tread through those waters, or whatever the expression is. Anyway, though, I think that'll do it for this video. If you liked it, looking forward to more. Thank you all so much for watching, and as always, I'll see you around.